Hello, welcome to stream of the day. uh, after some days. Let me check if everything's well or not. Let me just check if everything is going well or not. Yeah, the audio is going pretty well. So yeah, back after a long time because I had to go to somewhere else out of the town because I had some work, and also when I got back from town to my hometown, there was some power cut, so I couldn't really stream it. And today the power just came, so yeah, I'm here streaming it. Yeah, we'll just jump right into it. So from the previous stream, we had this window, a lovely little window, illus2D engine, and we also set up a FPS system. So it prints FPS every 1,000 frames. So yeah, it prints FPS every 1,000 frames, and we can see our FPS right here. We have this lovely little window. We're getting thousands of FPS, which is awesome because we don't have anything yet. And that's basically it. Check again. Yep, it's going well. All right. So the deal with today's stream is I want to set now. So as you can see, our window is empty. Okay, we obviously want something in our window. We want some sort of game, and we will start by drawing some primitives. We'll draw some triangles, we'll draw some rectangles, and eventually we will get into textures and maybe some lighting, some diffuse specular and all those stuff lightings, and then we'll begin loading some models and stuff like those. Okay, but first we will start with primitives like triangles and quads and rectangles and so on. So the way we draw primitives like triangle is firstly we need to specify the vertices, which I'll show you right here, which I had drawn before just to show you. For example, so if you want to draw a triangle, right? A triangle is made up of vertices, 3 vertices. So let's say v1, v2, v3. And the vertices contains data. For example, it may contain data for the position like x1, y1, but apart from position it can also contain some other things like color, right? And it can contain texture coordinates and stuff like those. So these are data. Okay, so we need a way to send those data for every single vertex to OpenGL, and OpenGL will eventually store it into our VRAM, our graphics RAM. So the way we send data down to OpenGL is by using buffers, or specifically Vertex Buffers. Buffers in a very simple way are just array of bytes, array of memory. Okay, they're not complicated at all. So buffer, for example, you can say Vertex Buffer, this is a buffer, just an array of contiguous memory of bytes. Okay, it can contain it can contain any type of memory, it can contain float, integers, characters and stuff like those. And then later OpenGL can extract the data it needs from here and use it to draw our shapes. And Vertex Arrays are basically Vertex Buffers with its layout, because like I said, Vertex Buffer by itself has no meaning because it is just a contiguous block of memory. There is no concept of like the first 3 floats, like the first 3 data into the Vertex Buffer is a position, and then the remaining 2 are colors. There's no concept of that. Okay, there's no layout in a buffer by itself. We need to specify the layout by ourselves. So a Vertex Buffer with its layout is a Vertex Array. That's basically it. That's basically how we're gonna solve our problem of drawing a triangle. And this stream is we are going to be setting up our Vertex Buffers, our Vertex Arrays, and hopefully, fingers crossed, we'll finally maybe just maybe we'll get to see a triangle in our screen. All right, so yeah, let's just get into setting up our buffers and just sending data to OpenGL. So under graphics, I'll just add a new item. I'll call it Vertex Buffers, Vertex Buffer. I'll call it Vertex buffer.h, and I'll probably add CPP file as well. And I'm getting messages here. Hold on, let me check it real quick. Yeah, I'll probably play some small music some small music. Yeah, I hope the music is not too loud. Yep, this much is okay. You need some music, okay, else you're gonna get bored as fuck programming. Alright, Vertex Buffer, I will obviously need to include glue for all our OpenGL functions. I'll make a Vertex Buffer class. Oh my god, I can't type. Private, public. Now, yeah, I'll make an ID for it. Unsigned. And Vertex Buffer object. Private. I think the music is a bit too loud. I'm not sure. Yep, this one's okay. Vertex Buffer object, and let's make a constructor to set the data. We'll probably take something like unsigned int data size and a void pointer to the actual data. Pretty cool. We'll include vertex buffer.h. We'll begin setting everything up basically. It's buffer, unsigned int data, void pointer data. Duplicate parameter name. Alright. After that, I'll probably create some functions to bind our buffer. So bind, void unbind. They're going to be const methods, of course, and I'll probably also create like a size something. Yeah, I can do that later on if I want to. Void text buffers. Bind. Why is it? Text buffer bind. Oh my god, I'm so bad. Vertex buffer. I'm messing up the spelling. Vertex text buffer. Vertex buffer. Yeah, awesome. Alright, void vertex vertex buffer bind. Finally I got it right. Const unbind. There you go. So let's just begin generating our buffers. We have glue.h included, so we can just get into it. So geo gen buffers. Generate one buffer at the address of vertex p and vertex buffer object. I'll bind the buffer. Now we have different binding points. So this is a vertex buffer and it's going to contain like the vertex data. We'll bind it to GL array buffer, and we have we have a separate kind of buffer. It's called an index buffer, and if we had that, we'll probably bind it to like a GL element array buffer. So yeah, which will definitely come in the coming videos. The buffer we want to bind is p_vbo. Send the data to the buffer. GL buffer data, GL array buffer size is the data size, and the actual data is data. Uses is, let's do static draw for now. And now once we finally get into something like batching and like drawing a lot of geometries, we'll probably change this from GL static draw to GL dynamic draw and stuff like this, but we don't need to dwell on this too much right now. Alright, so we'll send the data to OpenGL. We'll do GL bind buffer p underscore BBO. What the hell am I doing? GL array buffer PBO. Copy this and we'll bind nothing because this is an unbind function. Cool. So this is basically our buffer class. Like I said, buffers are nothing really big. You can see how small this class is because buffer is basically a array of memory. That's all it is. Okay, so we don't really need to like tweak it so much. That's basically it. That's basically our buffer class. Now of course we can just add something like, I can just add like here unsigned int data size, like the total data size, or I'll just put some like capacity. I'll put some the capacity and I'll probably set the capacity to 0. Yeah, p underscore VBO, I'll set to 0 for now. Set the capacities to 0. And here set capacity to be data size. Cool. Oh, nice. Okay. So Vertex Buffer down. Simple. So include files, graphics, Vertex Buffer.h, and hopefully put a comment here. Let's send data to OpenGL. Get in the Vertex Buffer object. Takes in a constructor, data size, and the data. So I'll just pass in something random for now. For example, 400 bytes, and it's going to be null pointer because we don't have the data yet. All right, cool. Yeah, so it works. It works. Cool. Now let's get into the vertex arrays, which is where the real fun begins. Which is where we can finally start implementing all our algorithm and stuff. Vertex. I can't type vertex for some reason. Vertex array.h and new item. Vertex array.cpp. Like C, I can't type for some reason. So vertex. Cool. Okay, vertex array.h. What do we have here? We'll obviously need to make a class. Vertex array. It's going to have a couple of private members. Unsigned. It's obviously going to have an ID of the vertex array. ID of VO. And that's pretty much it. This is not going to be anything big. Vertex array. Fine. Const. Let's implement those functions. Vertex array. Bind, unbind. You guys should know the drill by now. Let's generate a vertex array. So gl gen vertex array. Obviously we can't do that because we need to include glue gl glue.h. Now we can validate it. Gl gen vertex arrays. We'll do one vertex array at p_val. We won't bind the vertex array, we'll just do it here. So gl bind vertex array, not apple, bind vertex array. We'll bind the p_va vertex array, and let's unbind it real quick. Awesome, pretty cool. Let's include that as well. Files, graphics, vertex array.h. So we have our basic vertex array and vertex buffer class. Now what about the layout? Because that's the most important thing, because vertex buffer by itself has no meaning, like I'm preaching again. A vertex buffer by itself has no meaning. A vertex array actually gives it meaning because it stores the vertex buffer and the layout. So for the layout, I think it will be much better if I just make a separate class for it, right? So I'll probably just make a class again here. I'll call it vertex buffer layout, or I'll just call it VB layout, vertex buffer, short for vertex buffer layout. It's going to have a couple of private member variables. One of them is going to be unsigned in data p data count per vertex, data count per vertex. Really nice name. And it's going to contain a vector, so I'll have to include that as well. Include vector. I'll probably have to include IOStream as well. I'm not too sure about that. We'll see. So std vector can be a vector of integers, and I'll name it something like data per index, something like those. Data per index. I'll get my convention right here. P data per index. Yeah, that's basically it. So public buffer layout void set layout. Go to vertex array.cpp, vertex VB layout, VB layout, set layout. Awesome. I'll add a little comment here. So this is vertex buffer layout class. So it begins from here. So it's going to be easy for me. And I'll probably take in some constructor methods. So what do we do? So for the layout, we'll obviously need the index. So unsigned int index. So for what index are we setting it? And then we'll need the data. So how much data it is at that index. So it's also going to be an unsigned int data count at that index. So yeah, data count, and I'll put in unsigned int like what data it is. So unsigned int data type, and that's basically it, I guess. For now, I'll just add it if I need it. That's basically what programming is. You add it as you need it. If you don't need it, you don't need to add it. Well, you can if you want to look cool, but alright, let's get into it. Vertex buffer layout. So how do you actually get into it? So we have this index right here, and I think I'll probably just I'll keep track of an index as well. Unsigned int indices. indexes. No, I think okay, indices makes sense. Unsigned indices, and I'll set all of them to 0. So p underscore indices will be 0. Actually, it's going to be -1, and I'll show you why. P underscore data count per vertex is obviously going to be 0. Count per index also obviously going to be 0. I'll put it right here. Get rid of this, and I guess yeah, data count per vertex, data count per index. So yeah, I think I would have been better if I just put it cool. So data count per vertex, data count per now index. So basically my drill now, what my drill is, I want to increment the value of indices, p underscore indices by 1 every time the user calls the constructor or the settler. Well, the constructor is going to be called only once, so we can just increment p underscore indices here. So when I do this, so it's a -1 plus 1 is going to be 0, and that's exactly what I want. That's why I put -1 here. Now we're also going to be having to do this here. P indices plus plus, and we will index and data count, the type, yep. All right. So we'll do p underscore data count per vertex. We'll increment it with the data count per index, data count at that index, and we'll obviously have to copy this, do this. Of course, we'll have to. Actually, we don't need this index, do we? Now that I think about it, yeah, we don't actually need it, because we already have a variable that tracks all the indices, called the indices, and of course the indices are only gonna change when you actually call this method. So yeah, we probably don't need this index. Yeah, we probably don't need it. Let's get rid of it nicely. There we go. I'll get rid of that as well. And it's giving me error because it does not. Okay, nice. Set layout. We're probably gonna have to copy this again.